Okay, volumes of pyramids and cones. These are the pointy solids, right? They're just 1/3 the volume of prisms and cylinders. Let's see some examples. Here's a triangular pyramid and a square pyramid. Okay, if you remember the general formula, it was area of the base times the height. And that worked for prisms. For pyramids, we also need to multiply that by 1/3, which is the same as dividing by 3. So let's try it. We have 1/3 times, and then we need area of the base. In this case, it's a triangle, so we do 1/2 base times height. The base is 6, and the height of the triangle is this measurement right here, so that's 5. Then we need to multiply by the height of the entire object. That's the 10 meters right here that goes right down the middle of the pyramid. Okay, and that should give us our volume of a pyramid. I like to reduce a lot ahead of time, so I'm going to reduce by 2 right here. And then, since this is all multiplication, it's commutative. You can do it in any order, and you can reduce. So I'm going to reduce 3 out of both of those, and my volume is what's left. So all that's left is 5 times 10, which is 50. And since it's volume, it's measured in cubic units. So these are cubic meters in this case. All right, let's try this new formula for the square pyramid over here. Remember that we're going to do volume is equal to 1/3 always, area of the base times the height. So the area of the base in this case is just 16 squared because it's a square. And then the height is the internal height. We mean the height of the entire object right here. So that's 15. Be careful to know the difference between the height of the pyramid and the slant height of one side. We're not going to use the slant height for this problem. So now I have 1/3 times 256 times 15. And I love to reduce, so I'm going to reduce by 3 right away. It goes into 15 5 times. Okay? So my volume is what's left. That's 256 times 5, which is 1,280. And that is cubic units, which are inches in this case. And there's our volume. So general formula times 1/3. What about cones? That's the other pointy solid, right? Well, we're still going to use our general formula, area of the base, height of the cone, times 1/3. So let's try it. 1/3 times pi times the radius squared, which is 3 in this case, times the height, which is 7. Okay, I'm going to multiply out that 3 squared. So I've got 1/3 times pi times 9 times 7, and I can reduce. 3 goes into 3, 3 goes into 9. And what is left is the volume. So in this case, the volume is 3 times 7, which is 21, times pi. And cubic units would be cubic centimeters, or centimeters cubed. And that is the volume of the cone. Pretty straightforward. As usual, this is my exact answer in terms of pi, and you can approximate it by plugging in some decimal for pi and rounding if you'd like. So that's pretty easy. The only thing that remains is the question, why does it work? In this case, it's unfortunate but true that we're teaching the formula before you've had enough mathematics to understand the proof of why this formula works. Usually I can prove what we're doing, but you're going to need some college math under your belt before you can understand the proof. It's actually pretty complicated, even though it sounds so simple that it's just times 1/3. It's not simple. So that's all I can tell you for now, but you're welcome to research it on your own. And that is the formula for cones and pyramids.